Hello students, my name is Mahesh Mahale from Srimati Vimla Khilji Tejukaya Arts, Science and Commerce College, Devlali Camp, Nashik. In today's lecture, we will discuss the part of your syllabus from TYBSc Chemistry, which is Ionic solids. In Ionic solids, in today's lecture, we will focus on crystallographic types, which are classified by Bravis. So, what is crystallography? In a crystallography, a crystal system is a set of a point group. Means basically a crystal which is formed by a set of point group which are any imaginary point on space which are connected by an imaginary line. So, they form a crystal system. A lattice system is a set of Bravais lattices. Basically, Bravais is a scientist who discovers this lattice system. So, based on his discovery, the name given to the lattices are Bravais lattices. So, basically a space group are classified into crystal system according to their point group and into lattice system according to their Bravais lattices. So, crystal system that have a space group assigned to a common lattice system is combined into a crystal family. So, basically these crystal arrangement on in a space are classified into a different crystal system. So, these crystal systems are basically classified means they are mainly classified in a 7 crystal system. So, these are triclinic, monoclinic, orthorhombic, tetragonal, trigonal, hexagonal and cubic. So, these are 7 crystal systems which are enclosed in a crystallographic. So, these crystal systems are classified on the basis of their dimensions, means side, length and height. So, basically these are denoted by ABC, which is height, length and breadth. Then the angle between those height and width or height and length are classified, means on that basis these crystal systems are classified in 7 systems. So, in today's lecture we will mainly focus on a cubic system. So, a cubic system are further classified into three Bravais lattices. So, previously we have seen 7 crystal system which are classified on their height, length and breadth and the angle between them. So, these 7 crystal systems are further classified into 14 Bravais lattices. So, according to the system of arrangement of those lattices in a space, these crystal systems are classified into further classes. So, for example, in this system, in cubic system, the cubic system is basically classified into three simple systems, which are first is simple cubic system, second is basically a body center cubic system which is also abbreviated as BCC. Then we have face center cubic system which is abbreviated as FCC. Now, in a brief we will discuss in shortly. So, this is one of the system of cubic system which is simple cubic system. In a simple cubic system, as you have seen, there are 8 atoms which are placed in on the corner of that cube. So, basically they are the red atoms are the atoms which are placed in the corner of that cubic system. So, we have one cube and 8 atoms are placed at each corner of that cubic system. So, this is basically a simple cubic system. So, in a cubic system, as we are seeing that A, B and C, that is height, then breadth and the width are same. So, A is equal to B is equal to C and the angle between each line is basically a 90 degree. So, in a cubic system basically A, B and C means these are called as lattice constant. So, lattice constants are all equal and the angle between them is 90 degree. So, in simple cubic system, as we are seeing that the red atom is considering that the atom is basically spherical in shape. So, if an atom is spherical in shape, the 1/8th part of that atom is basically inscribed in that cube. So, by a calculation, if there are 8 number of atom which is multiplied by 1/8th of part which is inscribed in that cube, so we can say that only one atom is present, means one atom is enclosed in simple cubic system. So, only one atom is in that cube. Then we have a body center cubic system. In a body center cubic system, there are 8 atoms at 8 corners of that cube, and one atom is placed inside that cube. As you can see, there are total number of red atoms are at each 8 corners, and the blue atom is basically placed in the center of that cubic system. So basically that one atom is whole in that cubic system, and then we have a calculation that 1/8 atom of each red atom is placed inside the cubic system. So 1/8 into 8, as we have 8 corners, so 1/8 into 8, which is basically a 1. So total number of atoms in a body center cubic system are basically a 2. So in a body center cubic system, as we are seeing that there are only 2 atoms placed inside the body center cubic system. So diagrammatically, if we have to arrange those atoms in a well manner, these are seen in this video. So the red atoms and the blue atoms are stocked on each other, and they form a crystal system. So basically those red atoms are at each corner of that cubic system, and that blue atom is basically inside that cubic system. So this is basically a body center cubic system, which is we have seen now. So in a body center cubic system, the arrangement of those atoms, that is a red atom and a blue atom, is basically a AB type of system. So A atom, then the second A atom set is in those between A and A, there is sandwich of B atom, so they form a body center cubic system. Now a third type is basically a face center cubic system, which is abbreviated as FCC. So as we can see, as we have a cubic system, so cube have a 6 faces. So at each face there is a 1 atom, and at each corner there is also a 1 atom. So basically this is what the face center cubic system is, that is FCC system is. So by calculation, as we know, there are 8 atoms at each corner, and the 1/8 atom, 1/8 part of that each atom, that is a red ball which is present at the corner. So 1/8 part of that system or that atom is inside that cubic system. So 1/8 into 8 is equal to basically a 1. Then we have 6 faces. So at each face there is a half atom which is inside that cubic system. So if we consider this as only one system, so in the system the blue balls are basically at the face center, and that one blue ball which is basically sharing that one atom in 2 separate boxes. So one separate cube, consider the half of that atom. So as we have a 6 faces, so 6 into half is basically a 3. So how that comes is, basically we have half part of that blue ball inside that one cube. So half of that each 6 faces, so half into 6, which is basically a 3. And previously we have calculated for the red atoms, which are basically 1/8 into 8, which is 1. So 3 into 1 is basically 4. So in case of face center cubic system, that is FCC system, we have total 4 number of atoms inside that cubic system. So how this will be formed? Now we will see that how that a FCC cubic system is formed, that is a face center cubic system is formed. So as we have seen in a body center cubic system, we have arrangement of those atoms according to AB type. So basically A is one plane, B is another plane, or in a plane which have blue atoms, and in another plane we have red atom. So basically in this system we are seeing that there are three types of arrangement, or three types of different atoms which are representing that plane. So basically by video we will see that the arrangement of face how that face center cubic system is forming. So basically we have three types of layer. So red is A type, for example, B is B type, blue, then we have green or C type. So we have ABC type of arrangement of that atom. So this is how the body center cubic system is forming. So in this we are seeing that the red atom are recurring after a two layers. Means if we are considering that red atom is at one place, so after a red we have a blue atom, plane of blue atom, then we have plane of green atom, and then we have again a plane of red atoms. So they are basically recurring after a two sets. Similarly, if we are considering that blue atoms, so blue atom set is also recurring after a two sets, that is after a green and red we are again having set of blue atoms. So in that manner the crystal systems are forming. So these animations are basically taken from the techscience.com, which in that website you will further find the various crystal systems how they are forming. So this is how the body center this is how the face center cubic system is forming, that is FCC system is forming. So we will discuss short in case of hexagonal close packing. So in case of hexagonal close packing, the arrangement of those atoms are different from which we have seen in case of cubic system. So basically in cubic system, as we see lattice constants such as A, B and C are same. In case of hexagonal close packing, the lattice constant A and B are equal, but the lattice constant C, which is basically in height of that system, as we are seeing here, that the red atom, the set of one red atom and then set of second red atom, which is having that distance is basically a lattice constant which is equal to C. So the distance between in one plane we have a set of red atom, so that distance between those linearly arranged red atoms is basically A and B. So in case of hexagonal close packing, so lattice constant A is equal to B, but which is not equal to C. So C is basically height of that crystal size. So then we have an angle. In case of cubic system, we have seen that the angle alpha, beta and gamma which is equal to basically 90 degree. In case of hexagonal close packing, the angles are different. So basically the height, so C, and the angle between A or C is basically 90 degree, and the angle between the planar arrangement of those red atom is basically 60 degree. So in case of hexagonal close packing, this is a different kind of arrangement of those atoms. So if they are stocked in each other, so basically we have a set of red atom, then we have a set of blue atom, then we have a set of red atom again. So in one plane we have 7 red atoms, then one plane we have 3 sets of blue atoms, then again we have a set of 7 red atoms are arranged in such a way that they forming type of arrangement is basically AB type. So which is also seen in case of body center cubic system. So arrangement are quite the same, but they are not exactly the same. So crystal forming are different from the cubic system. So hexagonal crystal packing is different from cubic system. So these arrangement are basically the arrangement of those atoms are basically different in case of different crystal system. So in this we have ABAB system. So how these hexagonal closed packing is formed, that is HCB packing is formed, we will seen by a short video. So we have A type of atom, then we have B type of atom, then we have again A, then we have again B, then we have again E. So these systems are formed basically a ABAB system. So in that the atoms are arranged in a such a way that they form a hexagonal crystal system. So here we have a set of red atom, then we have set of blue atom, then we have again a set of red atom which are stocked in each other and they form a hexagonal closed packing. So in this way, this is what the short introduction to the crystal systems formed in case of cubic system and hexagonal system. So in next lecture we will discuss the remaining Bravais lattices. Means as we have seen in first slide that there are 7 crystal systems basically. So these crystal systems are further classified into 14 Bravais lattices. So in next lecture we will discuss the different 14 Bravais lattices and how the crystal system or crystal arrangement are present in those Bravais lattices.